For millennia, we have gazed at the stars, a tapestry of countless lights against the infinite darkness, and we have asked a single profound question: are we alone? This question has echoed through human history, whispered in ancient myths and shouted in modern science fiction. But today it is no longer just a question for philosophers and poets. It is a question that science is on the verge of answering. The universe is vaster than our ancestors could have ever imagined. Our own galaxy, the Milky Way, contains hundreds of billions of stars, and beyond it lie hundreds of billions of other galaxies. In this cosmic ocean is Earth, the only island of life. The search for extraterrestrial life has moved from the realm of speculation into the world of tangible, scientific exploration, and we are closer than ever before to finding an answer. Scientists have long suspected we are not alone, and their belief isn't based on wishful thinking, but on numbers. The sheer scale of the cosmos makes the existence of other life forms seem not just possible, but probable. Think about it. Billions of galaxies, each with billions of stars. If even a fraction of those stars have planets, we're talking about trillions upon trillions of worlds. This idea was famously captured in the Drake equation, a simple formula designed to estimate the number of intelligent civilizations in our galaxy. While many of its variables are still unknown, the equation forces us to confront a powerful statistical argument. With so many potential homes for life, it would be extraordinary if we were the only ones here. The universe is simply too big for Earth to be the only winner in the lottery of life. The key to finding these other worlds lies in the study of exoplanets, planets orbiting stars other than our sun. For centuries, they were purely theoretical. Now we've discovered thousands of them. Astronomers use ingenious methods, like watching for the slight dimming of a star's light as a planet passes in front of it, or observing the tiny wobble of a star caused by a planet's gravitational pull. Among these new worlds, scientists search for those in the habitable zone, often called the Goldilocks zone. This is the orbital region around a star where the temperature is just right, not too hot, not too cold for liquid water to exist on a planet's surface. And where there's liquid water, there could be life as we know it. We've found promising candidates, like Proxima b, orbiting our nearest stellar neighbor, and the incredible TRAPPIST-1 system with several Earth-sized planets in its habitable zone. Each discovery brings us one step closer, but we don't have to look light years away to find potential havens for life. Our own solar system holds tantalizing clues. Mars, our rusty neighbor, shows clear evidence of ancient rivers, lakes, and possibly even an ocean. While its surface is now cold and dry, life could still be clinging on beneath the ground, hidden from the harsh radiation. Further out, in the realm of the gas giants, we find moons that defy our expectations. Jupiter's moon, Europa, and Saturn's moon, Enceladus, are covered in thick shells of ice, but beneath them lie vast, global oceans of liquid water, warmed by the gravitational push and pull of their parent planets. These oceans could harbor hydrothermal vents, just like those on Earth's ocean floors where life thrives without sunlight, powered by chemical energy. Saturn's largest moon, Titan, even has rivers and lakes of liquid methane on its surface. Life there, if it exists, would be profoundly different from our own, a truly alien biology. This is where our most powerful eye on the cosmos comes in, the James Webb Space Telescope. This revolutionary observatory is a game-changer in the search for life. It has the ability to do something truly remarkable: analyze the atmospheres of distant exoplanets. As a planet passes in front of its star, the star's light filters through the planet's atmosphere. Webb can capture this light and break it down, looking for the chemical fingerprints of different gases, what scientists call biosignatures. These are telltale signs of biological processes like an abundance of oxygen, which on Earth is produced by photosynthesis, or combinations of gases like methane and carbon dioxide that should unexist together without a biological source constantly replenishing them. For the first time in history, we have the technology to detect the breath of another world. We are on the cusp of being able to point a telescope at a distant planet and say, something is alive over there. Yet, this raises a perplexing question. If life is statistically probable, and we're getting better at looking for it, why haven't we found anything yet? This is the heart of the Fermi Paradox. The universe is ancient. Civilizations could have arisen billions of years before ours, with plenty of time to spread across the galaxy. So where is everybody? Scientists have proposed many possible solutions. Perhaps there is a great filter, a series of evolutionary hurdles so difficult to overcome that almost no life makes it through. Maybe life itself is incredibly rare, or perhaps intelligent life is. Another sobering thought is that advanced civilizations may inevitably destroy themselves before they can master interstellar travel. Or maybe they are out there, but they are deliberately hiding, observing us from a distance. The silence of the cosmos is a mystery in itself, one that is as profound as the search for a signal. When we do find alien life, it probably won't be little green men stepping out of a flying saucer. The first discovery is far more likely to be microbial. Simple single-celled organisms are the most common and resilient form of life on Earth, and they likely would be elsewhere. Alien biology could be stunningly different from our own. It might not be based on DNA, or use water as a solvent. It could thrive in conditions we consider lethal. On a world with high gravity, life might be short and stout. On a low-gravity world, it could be tall and spindly. On a gas giant, it might float like a living balloon. The possibilities are limited only by the laws of physics and chemistry. The true face of alien life will almost certainly be more strange and wonderful than anything we've ever imagined. So, how close are we really? Some optimistic scientists believe we could find evidence of microbial life within our solar system on Mars, Europa, or Enceladus in the next decade or two. Finding biosignatures on an exoplanet with the James Webb Telescope could happen at any time. Upcoming missions like the Europa Clipper and new, even more powerful ground and space-based telescopes will continue to refine the search. It is important to remember that first contact will likely not be a spaceship landing on the White House lawn. It will be a spectral line in a dataset from a telescope. It will be the discovery of a fossilized microbe in a Martian rock sample. It will be evidence, not an encounter. But that evidence will change everything. The discovery of life beyond Earth would be the single most transformative event in human history. It would rewrite our textbooks and redefine our place in the cosmos forever. Science, religion, and philosophy would all be forced to grapple with the implications. Knowing we are not alone would shatter our cosmic solitude and connect us to a larger, universal story of life. It would force us to look at our own world and our own squabbles from a completely new perspective. We would no longer be just humans from different countries, but humans from Earth, representatives of our planet in a living cosmos. The search continues. We keep listening, we keep looking up, driven by that ancient, hopeful, and profoundly human question. Out there, in the silent darkness, another world may be waiting to be found. And when we find it, our own world will never be the same again. Thanks for watching.